Hi everyone, my name is Sucharita Roy, and I'm basically uh, I've worked on this project on creating multi-class uh, classifier to detect eye cancer for patients. Okay, so I've chosen a data set from Kaggle, which has about 5,000 patient records, and it encompasses across 16 columns. And so the goal over here is to help clinicians and guide them in the decision-making processes. So all these eye cancer patients, they have different kinds of cancer, and based on different features and variables, how they influence the stage of diagnoses. Uh, the course of action that's being taken, how it's affecting their outcome. So the outcome over here is my target variable, and it has three different classes: active, in remission, and diseased, hence making it a multi-class classification problem. So as you can see, this has been taken from Kaggle, and there's patient ID, age, gender, cancer type, date. You can see there's a mix of like numeric and categorical columns. Um, and this was chosen because it helps predicting the patient outcome, and it helps in reducing costs and making it more effective, and making it more effective for patients who really need it. If you're early detecting a cancerous patient, right, rather than wasting the resources on avoiding unnecessary treatments for other patients who might be in remission. So this really helps. So the four learners that I've chosen to create this were multinomial logistic, KNN, random forest, and XGBoost, because all of them have their own strengths. And I created a heterogeneous ensemble on top of it. And I also did stacking. And uh, the meta learner was created, which is also a multinomial logistic model over there. So we can, improve the performance and make sure that we are not we're making like correct predictions in a healthcare setting, and we're trying to I'll walk through that process. Okay, so over here, how the model has been created in general is that I took into consideration data shaping for each model, because each model I treated it as like a specialist, a clinical specialist, and it has its own requirements, and it takes the data in a certain way to understand the real patterns that's going on. Created a base model on top of it. Also, I did a 70-30 split here. So 70% goes into training, 30% has been hold out for testing, which we'll use for evaluation purposes. And I use k-fold validation to figure out the hyperparameter tuning part of it. So we ensure that the model works well. And then each model that has been created, I created a homogeneous ensemble of that. So for logistic, for Canon, they were backed, and random forest is already random forest and XGBoost. They're already uh, uh, ensembles of decision trees. So um, bagging was not considered for them because they already are. And then they were evaluated. And for evaluation, I chose macro F1 score, because precision and recall is better indicator than accuracy, because precision helps in figuring out, and because it takes the false positives into account, recall takes the false negative into account, and we want to eliminate that. We want to rightly classify the patients, and these are better metrics. And F1 score is a harmonic mean between precision recall. And macro F1, because it's a multi-class, so each class was taken into consideration to figure out their F1 scores and average, and that's how the macro F1 score was decided as the evaluating metric across all the models, to figure out which model is performing well. And yeah, and then the ensembles were created and also evaluated. And for the ensemble, the heterogeneous ensemble, majority voting was taken into consideration, because it's a classification problem. Okay, so um, I'm going to share my R. So just to get an idea of the data. So I loaded the data, I did a check for missing values. There were no missing values. I made sure that, the logistical regression and KNN, they need numeric features. So I ensured that the categorical ones were factorized. Also remove the redundant ones, which are not very useful, patient ID and date diagnoses, and then I did exploratory ones. So this first I clubbed the numeric columns to figure out the statistics. So I performed. So basically, on the numeric values, the histograms were created. I generated a heat map to figure out the correlations, because multicollinearity is also important for logistic regression. And you can see that, there are some blues here, which indicate some moderate relationship between the predictors, and scatter plot was created. And then over here, you can see for the numeric features, the histograms were created, and I also did feature engineering, and as like a part of that was creating the PCAs, which is the principal component analysis. And over here, I'll show that in the next chunk, that, this gives a normal distribution. This one has a right tail, right? So these were the data that I collected. So for feature engineering, even though there were not very strong relationships between them, but there were still moderate ones, I thought it would be good to reduce the dimensionality and improve performance. So so there were actually like 9 numeric columns, and they got reduced to 3. So um, that was part of the feature engineering, and I went over this, and each data shaping was done for each of the models. We can see that new numbers are more important for logistic. Also, I simulated missingness, because my data set was complete. So I simulated missingness in that, and then imputed them with a median. Outliers are important, so I handled the outliers. I detected them through z-score normalization. And so anything that's above more than 3 deviations were classified as outliers, and they were capped. So over here, the encoding was done. You can see that, and then they were scaled. All the values have to be scaled. It's extremely important, otherwise the results will be skewed. So yeah, and then for all of these models, each one of them had their own specifications. Uh, um, Hypertuning was considered. So first the base model was created, and then the hypertuning was considered based on the k-fold validation that was done, and k was 5. And then they were tuned to the best values of the hyperparameters. And so for KNN, we chose the best K value. You don't want to overfit, underfit. You want to choose the best value, and based on that, bagging was done. And so for this one, I had chosen 30 for logistic regression. And then they were evaluated. So for evaluation, I had taken macro F1, and you can see that the value comes out to be 0.3127 for logistic regression. For KNN, you can see that if I run them over here, also I've taken 30 for KNN. It comes out to be 0.33. So it does fairly little better. And for random forest, the macro F1 score is 0.325, which is okay. And then XGBoost. So random forest and XGBoost. XGBoost is better because it kind of helps correct the mistakes of the previous one and learns from that. So over here, the F1 score kind of came out to be much better, which came out to be 0.348. So then all of them were basically combined together, all the predictions, all the values that came from the tuned and bagged models for each one of them, logistics, KNN, RF, and then XGB, they were all combined in a data frame. And then, a majority vote was taken against them. And then based on that, the final evaluation was done. So the value came out to be 0.32, which is not good. I wanted the meta learner to focus on the strengths of each of the models. So the stacking was done, and when I run it, the values came out to be better. It came out to be 0.35. So over here, my learning is that the ensembles outperformed the individual models, and each model was specifically created for the data set. However, the values that came out were a bit modest. They weren't great. So I feel like the limitations that came here, it has to do with probably not having good features, and one can improve and get more feature. It can be more feature rich. You can, figure out more genetic markers, which can be more prone to, a strong predictor that helps figuring out the outcome. So, and this can also be rolled out and tested out in real life, just for testing, so it can keep learning. I hope these were my learnings, and thank you.